Okay, everyone. Thanks for joining us today. I'm going to go ahead and get started. Maybe some other people joining, but want to make the best use of our time and yours. So, just a little bit about me as an introduction. My name is Paul Stevens, and I'm the divisional sales director here at Maya. And I've spent over 20 years selling Siemens products, dating back to the SDRC Ideas days and beginning of Solid Edge back in the late 90s. For the better part of that time, I've been selling NX CAD CAM with an emphasis on CAM into industries such as the aerospace supply chain, automotive suppliers, and a few defense contractors. So my better half on this webinar is Andy Schaefers. He's a senior application engineer that I've been working with for most of my time selling NX. He's our technical guru when it comes to CNC programming and the CAM space in general. So with that, I want to take a few minutes to introduce Maya. And our agenda today. So a little bit about Maya. Maya HTT is an international channel partner as well as a software developer for Siemens with offices in the US, Canada, and the UK. Maya is the largest channel partner in North America with over 220 employees and a pretty diverse skill set and product offering. Our strengths extend from design and simulation with over 500 simulation projects completed to manufacturing with 50 plus years of combined CAM experience in multiple industries, to IoT and applied AI and software development, and also product lifecycle management with over 150 projects for Teamcenter completed. So, and that's maybe the tip of the iceberg. There's a lot to talk about there with Maya, but today we're going to focus on NX CAM. So we'll do a brief introduction of the general NX CAM space within Siemens, and then today's topic, which is shop floor integration. And then we'll do a little summary and have a bit of time for questions at the end. So the value of NX for manufacturing. First of all, we've got design and optimization in the additive manufacturing slash 3D printing space. A lot of really great tools in NX to help with the 3D printing equipment. We do NX CAM for CNC programming, which we've spent a lot of time on in these past couple webinars, or the past couple series in the webinar. There's the use of NX CAM or NX CAD to program using the digital twin of the entire job shop. NX for CMM inspection to control part quality and utilize your PMI data from your NX CAD model. There's the design of tooling and fixtures in the same environment. And of course, today we'll talk a lot about the shop floor integration, the industry-leading management of shop floor process documents, revision control, QMS compliance, and work instructions. So of course, this is the last one in our series for NX CAM. We talked a lot about 5-axis machining in our first one in CAM simulation validation last week. So shop floor integration, some of the challenges that we've heard from shop managers that we've worked with. How do you keep important process knowledge intact as jobs move through the shop? How do you move quickly while maintaining revision control and compliance to QMS and other quality systems? Shop floor documentation must be created efficiently and kept up to date. And some tools are being built unnecessarily because there's a limited knowledge of the tools currently on the machines. So in this session, Andy's going to show a demonstration of a robust system for tracking and managing process information through your shop. You'll see changes that are reflected quickly and managed by custom workflows. Quality management system requirements are met. You'll watch as an illustrated work instructions are created and updated with minimal effort using NX CAM. And you'll see why NX CAM users have confidence that relevant up-to-date process information is being sent to their machine tools. So with that, I'm going to go ahead and give it over to Andy.
Thanks, Paul. Let's just double check that I've got the Right, screen shared here. And can you hear me okay?
Yes.
Great. All right, again, thanks everyone for attending. Here are the 5 topics that I'll be covering as part of our shop floor integration today. The first one involves NXCam independently. I'm going to show you how you can utilize the work instructions capability that comes with NXCam. Then for the second topic, we're jumping right into Teamcenter, and that's our main focus today with an introduction to Teamcenter for manufacturing. And then our next 3 topics are built into Teamcenter. MRL is our resource and tool assembly management tool for Teamcenter. Then we have Shopfloor Connect, which is our managed DNC solution. And then finally, Manufacturing Process Planner, which is a virtual planner for your entire manufacturing process. Now, I wanted to start with work instructions in NXCam because I know many shops just aren't quite ready to jump up to something like Teamcenter yet, but here's something that you can really grab a hold of if you've got NXCam and make a difference in your shop floor integration with minimal effort or investment. What we're looking at then is the fact that NXCam contains a lot of knowledge and information that's helpful out on the shop floor. So the work instructions then are our pathway to get that knowledge out there. We make better decisions, of course, when we have more information and we can solve problems faster. A key part of this, and I'll show this at the end of the demo, is that the work instructions are very easy to update when changes are made to the process. And that's the kind of thing that's easy to invest in when you know that a change isn't going to cause you to have to rework many hours of your effort that's already been put in. Okay, let me switch over here and we'll show the demo. We tend to think of CAM systems as software applications that create G-code for our machines, but NXCam actually stores a lot of critical process knowledge. And a key part then of integrating our shop floor process is getting this knowledge in an up-to-date form out to the shop floor to the people that need it. I'm going to be showing you how we do that in a minute, but first, let's kind of look at some of the information that's available to us. Here I'm looking at the program order view and the operation navigator, and you can see I've got a list of all the operations as they're going to come out in the G-code. But alongside that, I've got associated the tools that are used in those operations, the type of operation it is, the tool number, and then the time required for each operation based on feeds and speeds that are input. This is all helpful information to us. Beyond just the operation information, we've got setup information associated with the fixtures, the blanks, and how they are laid out on the table. That's what we're going to look at now. Here's the drafting environment that comes with NXCam. As I create sheets in this environment, they're actually saved in the same file with all of my CAM operations. That makes management really simple. As you can see, I've already created a front view of our machine that also has the fixture and our blank. Now I'll show you how quickly we can turn this into useful information for the shop floor. First, I'll place a couple of reference dimensions here. We'll go up to the top of the blank from the machine table. And another reference that might be helpful might be the width of the stock or the height. Now let's place a parts list so that the setup person who is pulling these components can get the right ones. We'll choose parts list. And it's real easy to put these together in NX. All I need to do is use the assembly navigator over here, and I'll just select all the components that refer to Lang. Here's the parts list, and I can easily drag things around to reformat it. Okay, that's all the work I'm going to do on this drawing sheet for now. We'll see this pop up again as we complete our work with the work instructions. We've now looked at the information and knowledge we want to push out to the shop floor. So let's look at how work instructions does that. Up on the screen, I've got a documentation object, and it's living up here at the very top. So these are the first things that are going to come out when I create my documentation. On the left, I have sheets that I can create. On the right are formats I use to create those sheets. And these can be customized, or you can add to them. So the first thing I'd like is an operation list. And it requires 3 different pieces of information. The first is a product view. So I'm selecting a camera angle from which that image will eventually be taken. And then second is just some text. I'll just type in test text so you can see where this shows up. And then finally, we need context for the operation list. In other words, what level do we want the list from? And we want it from our top level here, the 1, 2, 3, 4. Okay, now we'd like to add a second sheet here at this level. And this sheet will be the drawing, the one we created just a few minutes ago. That's sheet 1. Okay, that completes this object. Now it's time to publish the work instructions that we've set up. There are several output formats, but we're going to choose HTML. You can see it reorienting the view here to create the snapshots at the locations that we specified. Okay, here's our preview. Recall this was the first sheet where we wanted an operation list and an image, and here's our test text. Certainly these columns are customized, but this is the out-of-the-box implementation. We do include toolpath time. Here's our next sheet. Recall the drawing that we created, showing some dimensions and our parts list. And then there are some individual images of operations to guide the operator. One of the most powerful things about our work instructions, though, is not something I've shown you yet. It's about the process of updating work instructions. I mentioned that we are only saving, for instance, the positions of the cameras, not the actual images. What this means is that if I go through and change the program, change something about the fixturing, that drawing sheet, the next time I want to create work instructions, I don't have to do this process all over again. All I have to do is republish, because all of the intent is stored in the program in NX in those work instruction objects. Okay, that's our work instruction solution for NX CAM then. Shifting gears, we're going to start talking about Teamcenter. That's our PLM solution. It certainly works well with NX CAM, but we're going to show you a lot of other solutions that we can integrate into Teamcenter for manufacturing. In this first demo, I'm going to give you an introduction to our interface into Teamcenter, but I'm going to do it using a common problem that we experience in machine shops and show you our solution for that in Teamcenter. I'm calling our customer part here the authority part, and we always need to be careful with these parts to make sure that they are not changed in the shop, that they're controlled, that we are tracking the revisions, and typically we want to have one source for truth with those parts. That's something we can easily attain with Teamcenter. But in many shops, these authority parts get copied all over the place, and it can be difficult to make sure that you're using the same revision. What I'll show you in Teamcenter today is that we have a where used search function where we can quickly find all references back to that authority part. This, of course, makes it much easier to facilitate compliance with your QMS system or other quality control systems that you might have implemented in your shop. Now I'll demonstrate the use of NX in a managed environment. Rather than looking for our files out on the hard drive using Windows Explorer, we'll be browsing for our files in Teamcenter using this active workspace browser, which is built into NX. I'll click on the folders here, but folders in Teamcenter are not the same as the folders you have in Windows. These folders just contain references to the parts. And so a part can have references in multiple folders then. They're here to help us keep things organized. I see here the part that I'm looking for. It's this 20166, and this is a customer part, which I'll call my authority part. This part is released, and it has a revision of A. A released part cannot be changed, and that's the state we want for our authority part. This is geometry that came from the customer. If a change needs to be made, the customer will send us a revision B, and we will likely obsolete revision A after we hook up our manufacturing process to revision B. I'm going to open this file in NX, as the next thing I want to do is create a manufacturing setup for this part. And so the challenge is, how do we create an associative setup, understanding that we can't write to this file? As we enter the file, we see a little reminder here in the tooltip. There's a padlock, and it tells us that it's read-only. All right, here's how we'll create our manufacturing setup. I'll create a new item, and NX understands that I want to reference that 20166-A part in. I've selected the type of machining that I want to do, and just by double clicking, I automatically get the next value for my ID. So when I click OK, I will have my new part, and I see that authority part there. It's referenced in as an assembly component. Next, I will create a wave link so that I have associative geometry locally in my new file. Now I can actually hide the authority part. When I look here at my part navigator, you see the result of the wave link I just created. I now have this linked body. What's the advantage of this? It allows me to make any changes necessary in this operation to reflect what's actually going on out on the shop floor. Here's an example. If you look, you see there's a very tiny chamfer there. Well, I might choose to create that in deburr, not in this machining operation. So I can use my synchronous tools and delete those edges. Also, in this operation, I might not be finishing these holes. I might want to leave those smaller so that I can put a bolt through there for the next operation. So it's important to note that I am changing the wave-linked body that I brought in. I'm not changing the authority part. In fact, if I redisplay it, you can kind of see it there in the background. This gives me then an opportunity to continue to be associative to that authority part and be able to trace that reference. But also, I have flexibility in the use of the synchronous modeling tools, so I can create this model reflecting what I will actually be creating out on the shop floor. Let's save now, and I'm going to return back to our browser. There are many useful features here in this browser, and we certainly won't have time to get to all of them. But there's one feature that's particularly useful for machine shops that I want to discuss. And the situation where it's useful is one in which perhaps there's a quality problem and someone asks, are we sure that all the process steps are using the correct customer revision? That question is very quickly answered in NX. I'm going to the Where Used tab here now, and this will show me all of the files which reference that authority part. So we see the 0809, the one we just created, but there's also an 807 and an 806. This is just one example of how integrating your shop floor with Teamcenter results in higher productivity. We're getting answers to important questions quickly. We're managing our uncertainty and making our shop more efficient. Okay, Paul, before we continue, let's put our first poll question up there.
All right. So we'll just take a minute here to have people answer this question. Kind of gives us an idea of where you're at in your business. Okay, Andy, might be getting close to everyone responding here.
Okay.
I'm going to go ahead and close it out and share the.
Well, it looks like we're all over the place here. And that's pretty typical, I think, Paul, is there's a lot of different goals that our customers have for integrating their shop floor. Well, let's continue here. We're switching gears to MRL. That's our resource and tooling assembly solution for Teamcenter and for NX CAM. There's a lot of problems listed here on this screen, but some specific ones that I might want to talk about are you may find a situation where you have near duplicates of inserts on your shelf because you had one tool ordered in, someone needed another tool, they didn't realize the inserts already existed, so they found something very similar. So that lack of knowledge across all of your tools often adds to duplication problems. And then situations like, say you want to change the insert on a tool that you use in many places, and you ask the question, which of our programs use this tool? That's often a hard question to answer, but with a tool like MRL, you can have the answer to that question in less than a minute. Let's kind of go through the benefits in terms of what we're doing here with MRL. We're starting with these vendor catalogs that contain parameter information and also 3D model information for the tool that comes through as a package into MRL, allows us to then turn those into components that we store and manage. MRL then allows you to build tool assemblies, which are then classified. Those are the tools that we're going to use in simulation, and we're going to integrate them fully into our CAM system. How does that look in terms of the larger picture here? Well, MRL is really this section right here, the component library and our assembly library. Once we have those tools created, we're going to use those in the CAM system to create the simulation. So at this point, we validate the program, but going across to the other side, then it's very important that the tools we use in the machine match what we did in the simulation. So MRL ensures this by creating drawings that are used for tool assembly setup, and Teamcenter can actually communicate directly with the presetter. So what we're doing is creating the mirror image between the virtual world and the real world on the machine tool. Here are the 5 kind of key parts of MRL. We've talked about the components and the assembly. Next, we're going to discuss vendor catalogs that make it much easier to get these tools into your system. And I'll just mention that MRL it stands for Manufacturing Resource Library. So it's not just tools. You can also store your machines, your fixtures, or any gauges in MRL, and then tie those to specific jobs. So again, we're following that job through the shop, understanding all of the resources inside Teamcenter. When tool components are loaded into MRL, we classify them. We are using an ISO standard that actually Siemens initiated about 8 years ago. That standard includes the classes that you're going to see here in a few minutes, but also the standardization for how the parameters are stored in the tool package along with that 3D information. So here we're going to do a quick demonstration of that capability. We're looking at the Teamcenter Rich client, one of the clients for Teamcenter. And here inside classification, you're seeing just a part of those 500 classifications that are available. Now, what's our goal here? We have a tool, an end mill that is close to what we want, but it's not the right length and it has the wrong radius. So we're making a copy of that tool, putting it in the resource manager. And you can see there on the right side, we've got the parameter view, the template view in the upper right corner, and an actual 3D view where we can spin the tool around. We're now making a copy of that tool and assigning it a new part number. Once that's done, you'll see that the parameters in MRL are actually driving the 3D representation of the tool. So here I am looking at the parameters, and I can change the length, the radius, well, whatever parameters I need. And that's going to then drive the creation of that tool component in NX. What this means for you is that you can have someone doing your tooling engineering that is not necessarily a user of NX. And here's where I'm updating the template, and you can then make a one-to-one correspondence between the part number in the tool manufacturer's catalog and your internal system where you're probably using your own scheme for creating part numbers for tools. Now, this step was not necessary, just wanted to show you that in fact that 3D representation of the tool is created, so it's going to be ready for use in NX CAM as soon as we turn it into an assembly. Okay, now let's talk more about those assemblies. We have many classes for tool components, but we actually have over 100 tool assembly classes. These we provide out of the box to customers. Of course, if you have your own ideas about that, you are free to create your own tool assembly classes. And what we're going to show here in a minute is our auto assembly techniques for taking those components and assembling them on the screen, not in NX again, but using the Teamcenter Resource Manager to put those together. So here's another video, and we're back in the Resource Manager. This time our job is to create a new assembly. So we begin by deciding what kind of classification is this. It's going to be a face mill. We are letting the system automatically assign the item ID, which you might think of as a part number. This then is sort of the empty container that we're going to use to put our tool in. Now, we won't take the time to fill out all of the information here, but you can see that there is a wide variety of parameters, much beyond what is required to make NX CAM work. And that's because the information and knowledge that's stored here in this tool is often needed elsewhere in a shop. Again, you're able to customize this. If you see parameters that you would like to add, you can add them to these tooling classes. Here we're doing a search for a particular component. We've selected a size we wanted, looked through our library, and found a face mill shell. So here's the connection between that selection and our 3D representation. Now you might look at this and think that we've sort of started backwards. Maybe we wanted to start with the holder and work our way down, but MRL is actually quite flexible. You can build your tool going either direction. In this case, we are using a guided component search because it knows, based on the type of pocket there, what inserts will fit. So it's only going to allow us to choose from inserts that can actually be used with this shell. Now we need to go the other direction and search from the connection at the top. So here we're selecting an arbor. And this should be enough components to complete our tool. Notice that the connection point is always known, so it literally is drag and drop to put your tool together. Here we're completing the parameterization of this tool by taking the information about the insert and adopting it upwards, because most of the information we want about that tool is the information about the insert. For instance, the radius, the depth of cut, the material of the insert, things like that. So you see that being populated there into our attribute values. Okay, now we're making the jump across to the CAM side. We just took our tool that we've created here in MRL, and we have now published it as a tool in NX. But if you look off to the right side here, you see we've also created a setup sheet for this tool. It includes a 3D view, a 2D representation, and then a parts list, similar to what we did for the work instructions. Here, the final attributes are being finished for the tool. And this step is, again, sort of unnecessary, but we are just opening NX so that you can see all this work was just done in MRL by someone who doesn't necessarily know NX, but they don't need to because that's done automatically for you in the background. Here we see some objects that are automatically created. We want a spun representation for the tool. In simulation, this lets us see when the spindle is on or off, and also that spun representation is used for material removal, making it much more accurate because it's a true representation of the material removal based on the shape of those inserts. Okay, let's return to our next step here, but Paul, I'd like to kick off that next poll at this point, the one about the number of tooling vendors.
We're just launching it right now. Give a minute to everyone answer those. Let's give it maybe 15 to 20 seconds here, Andy.
Yeah, this kind of surprises me a little bit. About half the people are only 1 to 4 vendors. That's a great achievement if you can get your vendor count that low, but looks like a third of our respondents are 10 or more. And we see that pretty typically in shops that you have specialized requirements that force you to go out to additional vendors to meet those requirements for your machines. And that just adds complexity to the job of managing those tools. So let's close that one off, Paul. Okay, so I've shown you a couple of techniques here for getting those components into MRL. Now, many of these larger tool companies, for instance, Sandvik, Kennametal, ISCAR, they have libraries already created. You can download that library and then create your library only from the tool components you purchase from that company. Again, that's very important that we want tooling engineers to be searching through what we have on the shelf first before they go off and select something else to purchase. Now, if you have a tool vendor that you use occasionally and they're not included here in this list, Tools United is a great resource for obtaining all those additional tools. Here, it's a quick video showing how that process works. We've got a really interesting implementation where Tools United is built into MRL. In the first part of this demo, we sort of start like we did before, where we're searching for a specific component. So here we're looking for a twist drill. Then we're going to put some search parameters in, and unfortunately, we're going to find when we conduct the search that we have nothing available to us in our library. So our job then is to go outside, find the component that's going to work for us, and bring it into our library so we can work with it in MRL. Now, a lot of this is just the search process through Tools United, which I'm going to kind of fast forward through, but you can see that the search is very similar to what we just did in MRL, but now we're searching through literally 1 million components that Tools United has. So let me fast forward a little bit. We're just drilling down into the area of the where the tool is in Tools United. We select that package and then import that package from Tools United into our library. Okay, once that's successful, we are going to map that tool into our system. I've mentioned this a couple times, but this is critical in that we want to have our own internal part number mapped to this tool while not losing track of where it came from and what the SIM source number is, or in this case, the Kennametal number is. Okay, let's see the results of that. Here are all the parameters on the left side for that tool that were automatically imported. And we also have a graphical representation of our tool. So here we see some more parameters, and in a second here, oh, sorry, yes, we're going to add our protruding link to the tool. And once that's updated, we've completed our task here. And there's the 3D representation of the tool. So that tells us that we were successful and that the component is available in both attribute form and 3D form to be used in MRL and then pushed out to NXCAM. Okay, now let's shift gears here a little bit. we're going to start talking more about the effects or the results of NXCAM, meaning a program, a work instructions, a tool list, and how we're going to share that information out to the shop floor. Some challenges that we face then with process planning are, in general, this process is not well integrated into most shops. These process planning takes place as small, discrete activities that are often not communicated well, and when problems occur, it makes it very difficult to track the knowledge across all these different teams. Also, inspection planning is another activity that often occurs separately. We see a lot of situations where you may be getting 3D PMI information from your customer, but you're not making use of it in your CMM operation. And then again, there's no integration back to your process planning. Here's the domain of our process planning then in Teamcenter. We're going to integrate and digitalize the entire value chain as part of our solution. We've shown you a little bit already about part model preparation and CAM. Coming up, we're going to show shop floor connectivity with our Shop Floor Connect. We've talked about validation in a previous webinar, and CMM programming is something we haven't really had time for. We'll also go through a demo today here of process planning, and we've shown you the tool libraries and the tool management. What we'll do then is take advantage of the Teamcenter backbone that already exists to manage all of the manufacturing process information in your shop. Here's a slide that shows sort of the physical shop on the bottom with our machinist, our tool setter, and then on the top, the people who are doing the planning in the virtual world to implement the process that's occurring out in the physical shop floor. Okay. Here are the three areas that are important to our process planning. We're starting with our design, then we're moving into planning and programming, and then finally we get the shop floor execution with things like our work instructions or our machine code. Let's do our first demo here of the manufacturing process planner and look at how this comes together. A process planner then has a job to do, in this case involving an artificial knee joint. On the bottom then are the real parts which exist for this job. We have raw stock, we have the part model, we have a stage model that represents a first or second operation result. Then on the top, we are going to use a template. Because we do these jobs often, we've created a template to guide us through the processing of this part on the shop floor. So at this point, the template on the top is not filled in, it is a roadmap for us. How do we make this, bring these two worlds together? We're going to take the objects from down below and drag and drop them up into the appropriate places in the template and assign them with the correctly classified type of object so that they're identified through our process. So here's the raw material going into its correct positions. And here we're classifying it. Next, we're taking our stage model, which is going to be the stock for a subsequent operation, and we're pasting it into our workflow. And again, classifying it correctly. Now, what's going to be the result of this? We are actually creating an NXCAM file that we're going to eventually push out to a programmer. Here we're attaching some additional resources. Now, we don't have a lot of time in this video. In this case, we're only putting in a milling machine. But as we saw earlier, MRL, of course, contains tool assemblies. We can actually attach those assemblies now. We could attach a fixture or a gauge. We can actually take templates of operation types that would be included in NXCAM and include those here as well. This is a situation then that allows a more experienced person to be working in Manufacturing Process Planner and guide less experienced programmers through the process by choosing tools and operation types, setups, machines for them. This also provides consistency in your operation as you're using these templates to guide you. They've been approved and everyone is understanding how we're going to create this artificial knee joint. So the last step then would be to let the engineer know that, that they need to take this job on, and what they're going to be opening then is a actual NXCAM file and begin their work with all of that template information pushed into it. Okay, Paul, we're going to start talking now about DNC, our Shop Floor Connect solution. I wonder if we could put that third poll up.
Yes, I will launch that. Maybe give it 30 seconds or so. Okay, it looks like we still have people answering the question here.
Yeah. Oh, interesting. We're not seeing anyone that allows, okay, no one is precluding modifications at the machine, but it looks like there's a slight majority of companies where the operators can modify the code, but they must alert engineering. And a slight minority that are just allowing the operators to modify and then storing those programs. Okay, in that context, let's continue here. Here are the kind of problems that we're trying to solve with Shop Floor Connect. It's not enough just to have a DNC program that allows you to get your G code from a server out to the shop floor, because you really aren't controlling anything at that point. It's so easy to get into a situation where you've got different versions of the G code. Something stored on the machine does not match something on the server, or perhaps you've moved to a different revision of the customer file and you're having trouble figuring out which program goes with which customer revision level. These are all important questions to be able to answer. And another part of Shop Floor Connect that's critical is all of this other knowledge that we've been talking about, things that are created by the work instructions in NXCAM, the tooling parameters that are created by MRL, or even when we were looking at our manufacturing process planner, there's process information there that can also be communicated and useful out on the shop floor. We allow connections to all of the popular controls, and we've got solutions for other oddball controls too, if you have one of those. And ShopFloor Connect is integrated directly into Teamcenter. So again, when you're looking to implement your ShopFloor integration with a single source of truth, the way we architected our solution really lends itself to that. So we're collecting all of that information that we discussed earlier, and it's in one place here in Teamcenter. Okay, this is best understood, and again, through a demo. So I'll start the video here. And we are going to actually begin with something that fails. We're going to create and send a program out. And after we choose the machine, which is our next step, you're going to see that this doesn't work out very well. Here we can have a quick view of that program before we send it. In this case, we're also viewing work instructions. Now, we only have these two types of files in this example, but many other resources could also be sent. And here I'm actually just looking at my part, which is a block with a hole in it. It's just an example. Okay. So here is the resource that we are sending to. So far we've looked at the program, the part. We've been able to, we're also able to look at the individual tools. And I pointed out earlier that MRL was automatically creating those tool setup sheets. Here you see a better view of one. So this is other information that's going to go out to the shop floor using ShopFloor Connect. And when we hit send, it fails. And the reason it fails is it's not released. It doesn't have a status of release. We talked about this earlier in the introduction to Teamcenter. In this case, then, this is a manufacturing engineer. They're going to release this part, and now it will be allowed to go out to the shop floor. Okay, so this is going to be successful this time. And we don't have a real machine tool for our demo here, but we do have a little folder that represents this machine. And so here we see that the NC code has in fact been sent there. Now we're going to imagine the operator making a change. He's changing that feed rate, and that's what he's run his part using. So what are we going to do with this? At this point, we sort of have two versions of truth. We have the program that exists in Teamcenter, and we have this altered program out on the machine tool. We need to reconcile this. We don't want to create a problem that is confusing in the future. So we will receive or upload that altered file into Teamcenter. We give a quick description of why we're doing this and the change that was made. Lets us know that that upload was successful. Okay, at this point, we want to go back into Teamcenter and look at the result of that. And here on the work list, I see a task to perform. That's German. And here we'll open things up and you can see that there are in fact two programs at this time. We'll go back into the manufacturing process planner to have a better view of that. And there they are. Let's open them both so that we can compare the data sets. We want to make sure that in the process of changing that feed rate, nothing else was changed that we don't know about. On the bars on the left, we see there's only one change. And in fact, we can verify that this is a valid program. And so now we can use a workflow to accept that altered code. So the altered code is now the released code. The previous code will now be unreleased and no longer available to the shop. Okay, Paul, we're going to wrap this up now. Shop floor integration is a huge topic, and I'm sorry we didn't have more time to spend with the individual solutions that we have here. But we hoped to show you today that NXCAM and Teamcenter contain powerful tools that you can use to integrate your shop floor. We'd also like you to know that at Maya here, we are ready to help you implement these solutions. It can be a big step to jump into a shop floor integration, but we have the experience and knowledge to help you plan out your implementation, and then we'll make it happen for you. At this time, Paul and I would like to open up the webinar to any questions that you might have. If you could type those into the chat window, or we'll pick them up as required.
Andy, I'll go ahead and ask a question as we're waiting for any other questions to show up. But during the DNC demo, the user sees the download failed, and he just releases the file and resends. How is that effective control?
Oh, sure. Well, if anyone could release the file, it would be uncontrolled, right? But in this case, the person who's doing that, their role in Teamcenter is as a manufacturing engineer. Now, what we demonstrated, because of time constraints, is a very simple workflow where he just releases and it's done. You could implement a more complex workflow where he initiates the release, but then it has to be approved by someone else in a different role before it's completed. So that's really at the discretion of our customers to determine what that workflow for release would look like.
Thanks, Andy. I don't see any questions. I don't know if you do there.
Not from my side, no.
Oh, there is a question here. Is there any connection or interface with a machining analyzer?
Let's see. I'm not sure what we're analyzing here. Can you give us a little more information on that question?
And that may be something that we just take up with you individually after the webinar here. We'll have someone get in touch with you and answer that. Oh, like a production module.
I think we're talking about a feedback loop here, which where we're informing the process based on the results of an inspection or something. But let's yeah, let's take that one offline, Paul. I think that's a bigger issue than we can address here in a few minutes.
Yeah. Yeah, we will get back to you guys with any questions that are outstanding. Thanks so much for attending today. Really appreciate it. And thanks for attending the general webinar series. So, thanks, everyone. Have a good day.